As promised, here are a few of these more difficult proportion problems. So let's go through question 7 and then maybe also question 8. This is on page 3 of the proportions and similar figures notes. Okay, so I'm going to start by getting rid of my fractions by using the cross product property. So I can go 15 times m equals 3 times m plus 1. Now I wrote it out this way to help me remember that that 3 has to multiply times each piece of the m plus 1. So that's going to give me, still got my 15m on one side, and then 3m plus 3 on the other side, because I have to distribute the 3. So now I just have my linear equation to solve. I'm going to get my variable together on the one side by subtracting that 3m over there. That gives me 12m equals 3. And now I'm just going to divide both sides by 12. So 12 divided by 12 is 1. That leaves us with m equals 3 over 12. Now both 3 and 12 are divisible by 3. So 3 divided by 3 is 1, and 12 divided by 3 is 4. That takes our answer down to a reduced fraction, 1/4. Or if you use a calculator, you can take 1, divide 4, and get a decimal answer, which is 0.25. Let's look at problem 8. Cross multiply. So I will have 5 times 4x plus 1 on one side of my equal sign. And then on the other side of my equal sign, I have 3 times x. Notice how my fractions are gone by using the cross product property. Don't forget to distribute. So we'll end up with 5 times 4 is 20. And 5 times 1 is 5. And then on this side we have 3x. Okay, let's go ahead and get our x's together on the same side. So I'm going to subtract 3x. But now that got everything on one side. Maybe I should have moved it to the other side instead. That would have been fine, but then I would have had a negative number. Not that that matters either, because now I'm going to have a negative number here instead. So since I decided to move the 3 over there, I've got to move the 5 to the other side. So it's going to be 17x equals negative 5. Now I can go ahead and divide both sides by the 17. Remember, you're always dividing by the number that's next to the variable, even though 17 is bigger than 5. Looks a little weird, but that's okay. So our answer is going to be negative 5/17. Now if you try doing this one as a decimal, you'll have a decimal that you'll have to round. So sometimes it's better to just leave answers as fractions, because then we don't have to get an approximate answer. We can just keep our absolute answer in the form of a fraction. Now if you were going to go ahead and find an approximate answer, 5 divided by 17, at some point you'll have to round it, because there's no way to write down the decimal and keep it entirely accurate without writing down a lot of decimal places. So I'm just going to write down as many as my calculator is giving me at the moment. But then if I wanted to, I could just round that to maybe 2 or 3 decimal places. And these squiggly lines right here tell me that I'm just finding an approximate answer for the fraction that is exactly negative 5/17. Oh, I just realized that I forgot to put a negative on my answer, because a negative divided by a positive is going to be negative. Alright, how else can we use cross multiplying to tell if proportions are true? We kind of already did a little bit of this, but let's do a little bit more where we actually cross multiply and see if we get equal values on each side to help us know if it's an actual proportion. So on one side we'll have 10 times 42, which is 420. And then on the other side we will have 26 times 16, which is 416. What do you think? Is 420 the same as 416? Nope, not quite. So this one is not a proportion. Let's look at number 12, or actually it's 11b. Same idea, 11 times 78 is 858k. Don't forget k's that are in there along for the ride. And then we have 13 times 63, which is 819k. Now right now, these do not look at all like they would be a proportion, right? And in fact, it doesn't even matter what k is. There is no number that k could be that would make the 858 and the 819 equal to each other. So again, this one is not true. Let's go ahead and try this one. Not sure what this one's getting at. I'm kind of curious, actually. So 6 times 2x minus 8 equals 3 times 4x minus 16. So that would be 12x minus 48. And another 12x minus 48. Look, I got the same thing on each side. So is that a true proportion? Yes, it is, because each side is equal to the other side. And it doesn't even matter what x is. It's still going to be true no matter what the variable x is.